So this last example that we're going to look together is really kind of a fun example for you to consider when you're thinking about the next time you walk up to an elevator. This says that suppose an elevator has a maximum capacity of 16 passengers with a total weight of 2,500 pounds. Assuming a worst case scenario in which the passengers are all male, what are the chances that the elevator is overloaded? Assume male weights have a normal distribution with a mean of 182.9 pounds and a standard deviation of 40.8. So the idea behind this particular question, when you walk into an elevator, if you look somewhere in around the elevator from the inside, you'll see that plaque which tells you the maximum capacity by weight. I don't know if it has the number of passengers or not, but I kind of think it might. And that's what we're dealing with right now. So from this scenario that we are given here, we know a couple of things. I know that the average weight, assuming male weights follow a normal distribution, so we have a normal distribution, that the mean of the population of men, so the average weight of men is 182.9 pounds with a standard deviation of 40.8. So let's just write that down first. I know that the mean of the population is 182.9 and that the standard deviation of the population is 40.8. And the question that I am initially answering in this first bullet says, what is the probability that if I were to select one male out of the entire population of men, so I'm going to look at one male out of the entire population of men, what is the probability that his weight is going to be greater than 156.25? So watch the way that I notate this. The probability that X, the variable X, some guy, one guy, what's the probability that I find one guy who's randomly select a male whose weight is greater than 156.25? So basically, this particular question is a question about the population. I've got the population mean, the standard deviation of the population, and I'm asking about some guy out of the entire population of all men. So that's a normal calculator question. Let's go to the normal calculator. We will put in our new information here by going to Stat, Calculators, Normal. We know that we have a mean of the men at 182.9. I've got a standard deviation for men's weight at 40.8, and I want to know what's the probability of randomly selecting some man who has a weight greater than 156.25. Well, that happens to be 0.7431. Okay, so let's write that down over here. The probability of that happening is 0.7431. So in other words, if I were to go out, the probability, the likelihood of me finding some guy out there in the world of all the men whose weight is more than 156.25 is going to be about 75%, right? So 75% of the men out there are going to have a weight that's greater than 156.25. So the second part of this question says I want to find the probability that in a sample of 16 men, that a sample of 16 males have an average weight or a mean weight of greater than 156.25. So what is the probability that if I were to gather 16 men up together, that their average weight is greater than 156.25? And I just want to kind of point out to you, if you're wondering where on earth did this 156.25 come from, the 156.25 comes from the fact that if the maximum capacity, if the total weight for my elevator is 2,500 pounds and 16 passengers are on, the maximum number of people are 16 passengers, then 2,500 divided by 16 means that it would be 156.25. That's where that comes from. So this question then down here is now about the sample. This question that we are about to ask is about a sample. Once again, it says that if I were to find a sample of 16 men, I'm gathering up 16 men randomly, and I want to know what's the probability that the average weight of those 16 men are greater than 156.25. So it becomes important for us to understand that this particular problem, again, is about the sample, because the mean and the standard deviation are about to change. In my sample, I know that the sample that we are interested in is 16. I know that the mean of my sample is equal to the mean of the population, is equal to the mean of the population, which is 182.9, because we were already told that. I know that the standard deviation of my sample is going to be the standard deviation of the population divided by the square root of the sample. Plugging that information into my calculator, I find that the standard deviation of the sample is 10.2. So the question that I'm asking now becomes, is the probability that my sample mean, and notice that I am looking at x bar now instead of x, what's the probability that my sample mean is greater than 156.25? Going back to StatCrunch, the sample mean stays the same, but remember the standard deviation is now going to change to the sample standard deviation of 10.2. So what's the probability then for that? Now notice down here in the probability that that value is 0.9955. So over here at 0.9955, think about what that means now. That says, once again, that if I were to look around and gather up a group of 16 men, the probability or the likelihood that the average weight of these combined 16 men is greater than 156.25 is almost 100%, or in other words, it's 99% likely that their average weight, each one of them, right, the average weight, I mean to say, of this group is going to be greater than 156.25. That means that, some guys might have weight greater than 156, some might have less than 156, but their average weight 99% of the time of these 16 men is going to be greater than 156.25, and therefore we have a problem for the maximum capacity in our elevator. So think about that next time you're standing there looking at an elevator and all of a sudden the doors open up, and for some reason 16 men are all standing there on the elevator. You might want to reconsider whether you get on. So our interpretation that we have here says that while there is only a 74% probability that any given male will weigh more than 156.25 pounds, there is a 0.99 or a 99% probability that the sample of 16 males will have a mean weight of 156.25 pounds or greater. If the elevator is filled to capacity with all males, there is a very good chance that the safe weight of capacity of 2,500 pounds will be exceeded.